Happy viewers. Myself, Dr. J. Abdul Bari, working as Associate Professor in the Department of Civil Engineering of K.S.Rangasamy College of Technology. In this video, we move to an important structural form, arches. Unlike beams, arches carry loads mainly through the compressions, which makes them highly effective. Arches have been used from the ancient stone bridges to the modern steel and concrete structures. Understanding how forces flow in arches helps us to design the longer spans with less materials. Understanding the fundamentals of arch. What makes the arch effective? An arch is a curved structural member that transfers the loads primarily as an axial compressions to the supports. Instead of resisting loads by bending, arches push the load sideways to the supports. This lateral force is called as the horizontal thrust. The shape of the arch plays a critical role in determining the internal forces. Why we have to study the arch? Why are the arches so important in structural engineering? Since because they have significantly reduced the bending moments, they are economical for the long spans, and they provide aesthetical appearance. Modern arches in steels and RCC resist both the axial force and bending, which making them ideal for the bridges, auditoriums, and industrial sheds. So the types of arches based on the hinges. The arches are classified based on the number of hinges as 3-inch arch, 2-inch arch, and fixed inch arch. The number of hinges determines the degree of indeterminacy, ease of analysis, and sensitivity to the temperature and settlement. A 2-inch arch is statically indeterminate with hinges only at the supports. In this diagram, you can able to see a 2-inch arch which has been hinged only at the support. More than the rigid, you can see here the supports has been hinged conditions. This is in case of 3-inch arch, and this is in case of 2-inch arch. So the 2-inch arch more rigid than the 3-inch, and the temperature sensitive and 1 degree of indeterminacy. Whereas in 3-inch arch, the 3-inch arch has hinges at the both the supports and at the crown. It is simplest to analyze, temperature effects are negligible, and no redundant reactions is necessary. Because of its simplicity, this arch is ideal for learning arch behavior. The number of hinges fundamentally determines the structural behavior, analysis, complexity, and sensitivity to environmental factors like temperature changes. And fixed hinge arch. A fixed hinge arch has no hinge. The arches are fixed at both the ends, which will have the horizontal, vertical, and a moment will be taking over in case of the fixed hinge arch. No hinges present in the fixed supports, creating a highly indeterminate structures, offering the maximum structural efficiency but complex analysis. The structural is efficient, however, the analysis is complex and requires the advanced methods. Now, the classification of arch based on the geometry. Based on the geometry, arches are classified as circular arch and parabolic arch. Geometry directly affects the bending moments, thrust, and structural efficiency. Circular arch is very easy to construct, aesthetically pleasing, but develops bending under uniformly distributed load. A parabolic arch follows a parabolic curve that perfectly matches the funicular shape for uniform loads, theoretically eliminating the bending moments entirely. Hence, most efficient for the bridges. So the equations for the circular arch will be given as x square plus y minus the r plus h square divided by r square. So this is the equation which has been used to find out the reactions and radius of the circular arch. This is the equation of the parabolic arch, that is y equal to 4h L square into x into L minus x. This is the equations for the parabolic arch. The choice of geometry significantly affects the internal force distribution, structural behavior, and the analytical approach required for the designs. So the analysis process of a 3-inch arch. Analysis of a 3-inch arch involves the 3 steps, that is finding out the reactions using equilibrium equations as summation of fx equal to 0, summation of fi equal to 0, and summation of moment equal to 0. and it determines the internal force at any sections, and we can able to draw the force and moment diagrams. The crown in the equations is crucial for calculating the horizontal thrust. So the internal force will be normal thrust, radial shear, and bending moment. It has been calculated using any method of sections. Next, reaction components in arch analysis. So the reactions in the arches include the vertical reactions and horizontal thrust. So the vertical reactions can be calculated with the help of the formula RA plus RB equal to W, whereas the horizontal thrust can be calculated with the help of the formula H equal to moment divided by h, small h. So horizontal thrust is a signature force in the arches and distinguishes them for the beams. Here MC is the moment at the crown if the arch were in the beam, and H is the corresponding rise of the particular arch. For 3-inch arch, reactions are statically determinant, and for 2-inch arch requires compatibility equations considering the elastic deformations. Next, internal force determinations. At any section of an arch, we can calculate the normal thrust, radial shear, and bending moment. The normal thrust can be calculated with the help of the formula capital N equal to H cos theta plus V sin theta. Radial shear can be calculated with the help of the formula VR equal to V cos theta minus H sin theta, and bending moment is being calculated using the formula capital M equal to moment of beam minus H into Y, where theta is the angle of the arch axis with respect to the horizontal and Y is the rise at the section X. These forces govern the design of the arch sections. Advantages of 2-inch arch and 3-inch arch. 3-inch arch is easy to analyze, tolerate settlements, and simple constructions, whereas 2-inch arch are more efficient, less deflection, and economical for the larger span. In summary, to conclude, the arches primarily carry the loads through the compressions, hinge conditions control the behaviors, and parabolic arches are structurally optimal. Thank you very much for your patient listening. Thank you very much.